Okay, so we are going to be looking at probability tree. We are going to be looking at the main tree, the reverse tree, and how to derive formulas from these trees. Okay, so we are going to be looking at the main tree, which is the probability of A and the probability of not A. We are going to be looking at these probability trees through the context of a test result in order to give us context and understand this better. So let's look at it as pregnancy test results. Probability of A would be representing the probability of a positive test result, and probability of not A would be representing the probability of a negative test result. Also, we know that even though you may get a positive or a negative, there's also a chance that that positive or negative could be true or false. So the probability you get a positive result and it would be true, which is the probability of a true positive. We'll be looking at B in the context of whether the results are true or false. So true for B and not like false for not B. Okay, so we're looking at the probability you'd get a true result, a positive result, and it would be true. The probability you get a positive result and it would be false, and the probability you get a negative result and it would be true, and the probability you get a negative result and it would be actually negative. Okay, so the probability of B given A simply means the probability of the event B has occurred, given that the probability the event B is occurring, given that the probability of A has already occurred. So this means we could only find out the probability of whether you get a true positive if we already know that you have a positive result. So the only way we can find out if your result was truly a positive or falsely positive is if we know that your test result was actually positive. And the only way we can also find out if your result is truly negative or falsely negative is if we already have the information that your test result was actually a negative to begin with. Okay, so now we'll be looking at how to derive formulas from the tree. So now the main branch here, as you can see here, the probability of A, which is the probability, as we said in this context, of a positive pregnancy test, would be given to us by the probability that you get a true positive, or it will be given by the general probability or the general number of people who got true positives plus the general number of people who got false positives, as you can see here. So the probability they got positives and it was true, and the probabilities they got positives and it was false. So now let's break that down. So we are saying the probability, this probability will be given us by the sum of these two branches, or the sum of its two sub branches. And we are saying in order to find the probability of A intersection B, or the probability of getting a true and a positive, would be the probability of B given A, which is the probability of a true given a positive, times the probability of A. So we can basically say that the end or the intersection here would be given to us by the product of the line. So this times this would give us this, and this times this would give us this, and that's how we go, like that. So we can say the probability of A is given to us by the probability of A and B plus the probability of A and not B, which you can clearly see here that has been broken down. Probability of A and B, according to the tree, is the probability of B given A times the probability of A, as you can see the breakdown here. And the probability of A and not B would be given to us by the probability of not B given A times the probability of A, as you can see stated here. And that is how we come up with the first equation, where the probability of A is equal to the probability of B given A times the probability of A plus the probability of not B given A times the probability of A. This formula we've gotten from the main tree. So these are deriving the formulas from the main tree. Okay, now the next step we are going to be looking at is the probability of not A. Okay, which, as you can see, the breakdown here, probability of not A is given to us by probability of B and not A. The probability of B given not A, and the probability of not B given not A. So the probability of B given not A times the probability of not A plus the probability of not B given not A times the probability of not A, which again is the sum of these two branches. So probability of not A intersection B and the probability of not A intersection not B would give us this formula, as we can see the breakdown here. So we are saying this, in order to get this, we broke this down. So the probability of not A being the probability of not A and B plus the probability of not A and not B, which you can see the breakdown here for the second equation as gotten from the main tree. So now we're going to be looking at the third formula, the probability of B given A. So now let's first get the probability of B given A. We already know that this is going to be equal to the product of this and this. If that is the case, a simple change of subject would give us the probability of B given A. As you can see here, a simple change of subjects, you just divide through by the probability of B, and therefore you get the formula. Great. Okay, let's get back on track. So as you can see here, the probability of B given A, according to the tree, would be, okay, the probability of B given A would be the probability of A and B divided by the probability of A. And now we know the breakdown of the probability of A and B because we've previously calculated for that, and we put the breakdown here. So we just insert the expressions into the equations to get the formula. And that's how we calculate for probabilities using, or that's how we derive probability equations from the main tree. As you can see, so the probability of not B given A, which is this one, would be this divided by this. I hope you're all following. It will be this divided by this. And we already know the breakdown of this from the tree. So the breakdown of this would be this times this. So the expression again was broken down and placed into the equation. We've already calculated for the probability of A, which is this equation, our first equation, and that's what's inserted into this. I hope you are all following at this point. Same applies to the probability of B given not A. Generally, the same principles. You look at the tree and you derive the equations from the tree. So as you can see here, the probability of B given not A, probability of not A intersection B over the probability of not A. Please let's remember the context. So we said, in order to shed more light, we said, so the probability of not A and B would be the probability of A, or the probability of B given not A is the probability of a true negative. The probability of a true given that it was a negative. Okay, I hope you all understand that. And the second branch, before we go there, let's just focus on this formula for now. So we broke down the probability of not A intersection B over the probability of not A. As we broke it down earlier, we already have in equation 2 the probability of not A. We inserted that into the equation, and we also find the probability of not A intersection B from the tree. not A intersection B, which is here. So it is equal to this times this, or the product of this line. Okay. I hope you're all following at this point. Same was done for the probability of not B given not A. Okay. So now the second thing we'll be looking at, like I stated earlier, would be the reverse tree. So now we are looking at the reverse tree. The reverse tree will be could be considered as a direct reverse of the main tree. So we are looking at the probability of B in this context. This tree, or the purpose of us deriving this tree, is to help us later on prove Bayes' theorem. Okay. So now we're going to look again at how to derive formulas from the tree. As we stated with the main tree, the intersection of the line would be given to us by the product of that line. So the probability of B intersection A will be given to us by the probability of A given B times the probability of B. And that's how the others come. I want us to understand clearly how to derive formulas from the trees, because that is key in understanding how to get or prove Bayes' theorem using the probability tree. Okay, so yes, let's keep going. I hope you all understand this. This is the diagram for the reverse tree. Okay, so this is how we derived the formulas for the reverse tree. Probability of B giving us the sum of the two sub branches, which can be broken down as the product of these two and the product of these two. So the sum of this product and this product. Also same for this one, the probability of not B being the sum of this product and this product. Product here means multiplication of the two values or the two expressions. Okay. And that's how we got equation 1, as you can clearly see here, which is the breakdown of the probability of B and A and the probability of B and not A using the reverse tree. Okay. By now, we should be able to understand how to use a tree to derive how to use a tree to derive expressions, as you can see here. Same concepts as how we get the equations from the main tree. Now let's look at the purpose of this, or why we are learning all of this. We are learning all of this to prove Bayes' theorem. As you can see, one of the guiding principles of Bayes' theorem is the intersection. We look at the intersection as this. We know that the intersection or intersection points are they are the same regardless of how you turn things around. So let's look at this Venn diagram here. So if we had a set A which contained 1, 2, 3, 4, and we had a set B which contained 3, 4, 5, 6, our intersection points would be 3 and 4. Now A and B, if you're looking for the values of A intersection B, it's a 3, 4. And if we turn this around and we are looking for the intersection of B and A, it is still going to be 3, 4. Okay. And that is the guiding principle. Basically, we are saying if you have the probability of A and B, it would be the same as the probability of B and A, meaning the result would always be the same, or the set would always be the same. So probability of A and not B would be the probability of not B and A, and the probability of not A and B would be the probability of B and not A. As is the last one, which is the probability of not A and not B would be the probability of not B and not A.